All right, welcome everyone. I'm Kelly Goetsch, Chief Product Officer of Commerce Tools, and I'm here to talk about 5G. I was actually in Helsinki, where my brother lives, last year, and we went to a symposium on 5G. And I thought, wow, this is really cool for commerce. A lot of interesting use cases here. So I thought about it and ended up, I guess I'm here. So let's get started. So first thing we have to remember is even as early as 2016, so 3 years ago, more traffic on the internet came from mobile devices than from desktops. So the days of solely transacting through websites on digital, on actual desktops is long gone. And I still think there's a lot of traffic there for sure. And it still accounts for more than half of revenue. But a lot of the browsing, the shopping, the buy online, pick up in store, mobile is really everything. And what's interesting, and I didn't know this, but there are actually more cell phone connections in the world than there are toilets, which is pretty remarkable. So lots and lots and lots of folks out there have access to mobile phones, and that's really the next frontier of commerce. People even do text message-based commerce, which I didn't know was a thing, but we've even had customers request it from us. So not even chat, but text message-based commerce, if you can imagine that. And going back in history, before 1G, so back in the day, people had point-to-point radio communication between cell phones. They weren't even cell phones, they were radios back then. And they were primarily used for military purposes. And those were literally point-to-point connections. They were all analog, right? It's just modulating the voice up higher. And that's what the first generation of cell phone technology was. It was simply modulating voice above 150 megahertz. That was it. And it would route it to a local tower, and then that tower would then put it into the telephone network and switch it appropriately. And that was great because back in the day, you didn't really have any mobile phone choices, right? It was strictly physical plugged-in phones. So, you know, these guys in the 80s and 90s, you know, having their phones, the bricks against their wall, against their ear, they were pretty excited about that. And it was a good time. The challenge though is it's strictly analog. So there was no text messaging, there was no video, of course, there was no broadband. It was 2.4 kilobytes per second. That's all you would get, right? So it was strictly a phone. It was a complement to the existing cell phone network. What was nice about these phones, and I actually remember, I guess I'm dating myself here. I remember using these because you could, when you were camping, they were the only phones that were capable of getting connectivity. So long into the 90s, even into the late 90s, in the US at least, a lot of people who would take canoeing trips or camping trips or things like that, we would still use first generation because it was all analog, and those cell phone towers could reach great distances because, I mean, all you're doing is it's all analog. It was really, really basic. Another challenge with these is that the handoff between towers was really tough. So if you're in a car and you're driving on a highway, chances are you would drop the signal all the time. And it was because the handoff of your voice from one tower to the next tower was always an inherently error-prone process, and the protocols just didn't really work. So as a result, it had a very high drop rate. Another issue, it was completely unencrypted. So if you were within range, you could tap anybody's phones. So it was very much like the party lines back in the 50s and 60s. And thankfully, I'm not that old. But my understanding from relatives is you could dial in and there would be a community party line, and anybody in the neighborhood could listen to everybody else's discussions. And it was the same thing here with 1G. Right? If you had the right equipment and it was pretty easy to procure, you could just tap into somebody else's calls very easily. But these networks have largely been phased out. They were first introduced by NTT in Japan, and they have been phased out years ago. So that is good. Next, we have 2G. This was the big one, right? This was real cell phones is what I would call them. This is the precursor to all of them. And that was introduced in '91, and it was between 64 kilobytes and 144 kilobytes. And I don't know if you remember these devices. This was actually my first cell phone a long time ago. I still remember my wife, my girlfriend and now wife, actually sent me my first text message, and I freaked out because I didn't know what it was. This is a long time ago. Anyway, finally supported text messaging. It supported MMS messaging, so you could send pictures, even though you couldn't take pictures with phones. But this was really the precursor to modern phones. The problem with them, I mean, it's a good thing, but the problem with them is they were all packet switched. So rather than it being an analog, rather than just modulating your voice up and transmitting it to a tower, it was encrypted, and it was actually digitized and then passed to the tower as a digital signal. But the advantage of that is, of course, you can get text, you can get data, you can get lots of things. The throughput's a lot higher. The issue, though, is you have to have lots and lots and lots of these towers, because now it's not an analog signal anymore, like a radio signal. Instead, you have to have these every few kilometers, basically, right? So it's a different technology. But this 2G and GSM specifically is when we started to see mainstream adoption of cell phones. I also had this phone, and I thought I was really cool when I got it. Was, again, a while ago. But this is the real smartphone era. Edge, this is 3G. And if you look at your phone now, it probably says 3G on it, because a lot of the connections, especially in Berlin, are 3G. And you find 3G just about everywhere. 3G is actually an implementation of the GSM specification. So EDGE stands for Enhanced Data Rates for GSM Evolution. And this is 2 megabits, so this is actually pretty reasonably fast. This is theoretical megabits. Everybody knows that you can't actually get a 2 megabit connection on a mobile phone, but in theory at least it could support 2. And that's when we got the term mobile broadband, and that's when people started to get Blackberries, or back in the day people would call them Blueberries, because Blackberries made blue phones and everybody thought they were really funny by calling them Blueberries. But you know, this was real. These were real smartphones. What's interesting, just a quick tidbit: the first iPhone, when it was introduced, it actually didn't support 3G. It was a 2G device back in 2007. So it was only later in 2008 that they actually added 3G Edge support. So this is all evolving pretty rapidly. Next, you have LTE and WIMAX. WIMAX isn't really widely used, despite its name, but LTE is just about everywhere these days. And if your phone does not say 3G, it probably says LTE on it. And this is modern devices. If you go to your local Apple store and get an iPhone, it's going to support LTE. And LTE is great. It's much faster than its predecessor, so you can get up to, in theory, 150 megabits. In practice, it's a couple megabits, and that's because it's still a pretty error-prone protocol. What's interesting, though, is it's entirely digital, the entire network from top to bottom. So it's true voice over IP from end to end. And it's suitable for all sorts of use cases. So movie streaming, video, just about anything you would want. Actually, enhanced versions of 4G, so they call it 4.5G or 4.75G, those are actually being rebranded as 5G, but it's fake 5G. So some of the carriers in the US just flipped a switch on the phones. They pushed an upgrade, so a lot of people's phones in the US now say 5G magically, even though it's not 5G. They call it LTE evolution, which is still LTE, but not 5G. All right, now we get to the good stuff. We get to 5G, which I think is pretty spectacular. The spec was just finalized in late 2017, so it's still pretty new. It still will evolve a little bit, but it's becoming more final. The first deployments were actually late last year, late 2018. So this is all brand new, and they've deployed it to just a handful of cities around the world. I think they did Austin, Texas. They did the Olympics, just a very few implementations of it. So it's still a very, very new and emerging technology. But over time, this will become the only standard we use. What's interesting is in real world use, they expect mobile devices that are stationary, right? So if you're standing in one physical spot, to get more than 10 gigabits of throughput per second. So that's real world expected use for a fixed connection. If you're moving, you can take about 50% off of that, if not more, because when you move, it reduces the effectiveness pretty substantially. What's also really impressive about it is it eliminates almost all of the latency from the protocol. So rather than 33 milliseconds of overhead introduced by LTE, we get below 1 millisecond of latency between the physical device in your pocket to the tower itself. Right? So there's over the air, but that doesn't really account for anything when you're connecting to a tower. But the protocol itself is less than 1 millisecond of latency. And I'll get into why that's really interesting. And I'll talk about this a little bit more as well. But what's interesting about 5G is it uses a much higher frequency. And therefore, you have to have towers every couple blocks. So they're not good for rural areas. 5G, I don't think, will ever be deployed out to rural areas, just because the economics don't make sense. But for cities, for populated areas, 5G makes a lot of sense, although it'll take a while. This is the Gartner hype cycle, and I think it's important to remember that with a lot of these terms, they are dramatically overhyped, and we can't think they're going to solve world hunger, even though people are saying that about 5G, which is ridiculous. Anyway, Gartner has this hype cycle methodology where any new technology starts with an inception, and then it gets hyped, and then everybody gets disappointed because the hype doesn't match reality, and then there's a long plateau of productivity over time where we actually start to see value from that innovation. And 5G is just climbing up that right now. So I would expect over the next year or two to see much, much, much more 5G hype. I think a little bit of it is warranted. 25% of that hype is warranted. I think a lot of it is overhyped. And I think folks will figure that out pretty quickly. But they're really interesting commerce implications. Gartner actually predicts within 2 to 5 years that it will become mainstream. So that's what they're saying. I think it'll be a little bit longer than that because of the economics involved, but I think it's an interesting number at least. The challenge with 5G specifically is devices need to support it, and there's only one cell phone device that I know of that actually supports 5G that you can buy right now. And it's because there aren't networks, and it's a chicken and egg problem a lot, right? Even Apple is not introducing 5G support until their 2020 iPhone models. So at least a year and a half from now is when the first iPhones will actually support it. You can buy cards that you plug into your computer, and that's actually this card right here. It's the Qualcomm. It's a Snapdragon chip. You can get those, and those are actually great replacements for fixed broadband. So a lot of neighborhoods are being torn up, and they're putting fiber networks in to every single house across the network. The challenge is nobody wants their streets torn up. And with 5G, you don't have to. Right? You can put one of these in a neighborhood within a few block radius, and everybody in that neighborhood could then get fixed 5G at, let's call it 10 gigabits per second, which is already much faster than we have today. But it will be a while before it's fully mainstream. This is what The Economist, the magazine, predicts will be its adoption. So 4G will continue to grow. 3G and 2G are declining pretty quickly and are mostly used in emerging markets. But we see 4G and 5G really taking off here. And I would imagine in 10 years, 5G will just be the standard. But it will take a long time. I was talking to a former colleague downstairs when I was checking in, and he said, well, what's your talk about? And I said, 5G. And he said, oh, you should know. The spectrum is being auctioned off right now, which I didn't know. So I Googled it, and sure enough, in Germany, the 5G spectrum is being auctioned off as we speak. So that's a multi-week process. I thought it was kind of interesting. But that just shows how early we are still, right? It's still very early. In some countries, in Korea, for example, it's already being much more widely adopted. What's interesting about 5G is it uses a much higher frequency in the spectrum. So 2G, well, 1G was in the megahertz. 2G is 1.8 gigahertz, right? And we go all the way up. 3G is from 3 to 300 gigahertz, right? And just in terms of frequency. So it's a much denser connection, right? It's much higher frequency. And what that means is it's really difficult to penetrate through buildings and other things. If you have radio waves, like old school point-to-point radio waves or 1G, right, you could penetrate concrete bunkers. You could do just about anything because the waves are much farther apart. But with 5G, it's almost like Wi-Fi, right? It's roughly the same, and it just doesn't work through solid concrete structures or anything else. So as a result, you have to put these literally everywhere in bigger cities, right? They imagine every corner in a big city has a 5G tower. So as you can imagine, the investment required is going to be in the hundreds of billions of dollars over the next decade. But it will happen. Telcos have spent billions of dollars on spectrum. This is happening. It's just going to take some time yet. All right, with that, let's talk about some commerce and future use cases. Yogi Berra was a very famous baseball player, which I just found out today, Germans don't know who he is. But Americans actually, he coined a lot of famous phrases and everything else. So he lives on, even though he died a long time ago, he lives on and has coined many of the popular catchphrases. But he famously said it's tough to make predictions, especially about the future. And I think it's very fitting here. With a lot of these really foundational technologies, think the internet, you don't know what happens on the other because of those inventions. Who would have thought that because of Ethernet, we now have the ability to summon an Uber with our mobile phones, right? So it takes decades sometimes for the true value of these innovations to come out. And I can pontificate as much as I'd like, but I cannot read the future. So these are some interesting ideas and some things I've been discussing with colleagues. So first is with 5G, you get a lot more bandwidth. So the time to download an entire DVD, 4.7 gigabytes, is 4 seconds, if you can think about that. Right? It's a ridiculous amount of bandwidth. And I remember using Napster back in the day. Don't tell anyone. And it would take an hour to download an MP3 file. Right? It would take forever. And now the ability to download an entire DVD in 4 seconds is pretty remarkable. And if you put that in context, again, this is from The Economist, you can just see dramatically how much more bandwidth is available by 5G. And the benefit to commerce, and I think this is going to be a really big one, is in AR and VR. So AR is augmented reality. Those are traditional glasses, and the real world is behind the glasses. So you're augmenting reality. I don't know if you remember Google Glass and the whole glass holes controversy. Anyway, people used to walk around with Google glasses on, and they didn't like them, so they called them glass holes. Sorry, Silicon Valley humor. But what's interesting about them is the functionality of the original Google Glass was very limited, and the functionality of these current headsets is very limited. Because you can't stream, you have to process everything locally, right? So if you're doing object recognition, for example, from an AR device, you have to compute that locally because there's not enough bandwidth and there's too much latency. And the use case would be if I have a pair of these glasses on and I'm walking through an airport and I see a coat that I like, if the AR glasses are transmitting a live video feed of what I'm seeing up to servers that are running algorithms to find out what that jacket is, in theory, through my AR glasses, it could pop up a buy button so you could buy that item. But the only way you reduce the size of those glasses, and those glasses are enormous, right? They're huge goggles. right? They're full computers mounted to your head. The only way you can reduce that, the size of those, and make them into normal headsets is if you push the processing somewhere else. So with 5G, you can transmit everything from a local device, which is now a dumb device, transmit it somewhere else, execute all of that functionality, whether you're doing object recognition, facial recognition, personalization, whatever it happens to be, and then execute that all on the server, and then have reality augmented over, the virtual part augmented over reality. So it's true VR, and it would make these devices much more accessible, and it would bring the cost down too. So we have a HoloLens that we've been playing with at Commerce Tools, and it was $2,500. It's a ridiculous amount of money, and it's a full computer that's attached to your face, and nobody wants to walk around with a full computer attached to their face. But I can absolutely imagine some entrepreneur putting a 5G chip in a pair of glasses and executing all of that functionality on the server side through the use of 5G. And you could do the same with complete virtual reality as well. Virtual is when it's in your face and you can't see the outside world. So it's completely blocked. And an example of that is the People's House. So this is available on Oculus, which I've been playing with as well. And it's a really cool, immersive 3D experience, right? You actually get a real tour of the White House. The problem with it is that it's 6.24 gigabytes. So you have to download the entire thing in advance before you can start using it. And that's challenging, right? It's tough. And imagine people having VR headsets on buses and being able to stream all of their VR experiences live without having to connect to Wi-Fi. And that's a pretty impressive experience if you could do that. So I think that'll happen. The next advantage, and this isn't a huge advantage, but still, page weights are increasing very, very dramatically. This is the homepage for Zalando, right? It's 5-point-something megabytes. And on mobile devices especially, it takes a long time to load the full page. And I know, right, there are sessions about this here at this conference, but imagine not having that constraint and being able to embed full video. Imagine being able to embed many more images. And with 5G, whatever latency there was with 4G, it's completely 100% eliminated. So people can, and by people I mean marketers, can be much more creative in the types of experiences they deliver to their customers. You also, as a consumer, don't have bandwidth caps and data caps. And there are some experiences that folks aren't able to do because they hit their monthly caps, right? That's very common. So imagine if you have to download VR, for example, right? And you want to take a look at a vehicle before you go buy the vehicle. You could do that in VR, but it would be a 10 or 20 gigabyte download. And if you have a data cap on your plan, downloading one 10 gigabit file is pretty terrible, right? You suck up your whole bandwidth or your whole data for the month. And with 5G, if you could get 20 gigabits in a second or 2 or even 3, you can now be freed from your data caps. So I think that will certainly promote commerce. The next advantage is lower latency. And to put that in perspective, if you look at the latency overhead, we've gone from 300 milliseconds down to less than 1. And I think that's pretty impressive. So there's the standard, right? If you look at a lot of these web pages and other apps, there are lots and lots of requests. There are many times hundreds of requests that your browser has to make. So those will certainly get faster, which is great. But I think the big advantage is in delivery. So true autonomous vehicles, whether they're on a highway or whether they're on a sidewalk or whether they're flying in the air, they have to communicate with each other in real time. So if you have 2 drones in the air delivering packages, they have to communicate synchronously in real time. You cannot have a 33 millisecond latency overhead in communication between 2 devices that are flying at each other very, very quickly. It doesn't work. Same with vehicles on highways, right? If you are driving an autonomous truck, trucks have to communicate with each other in real time, right? They cannot tolerate tens of milliseconds of latency. And you could actually do that now with 5G, assuming you have coverage. The next is low power consumption. So 5G, the actual protocol is much less power intensive than 4G and previous generations. And as a result of that, IoT manufacturers are targeting 10-year battery lifespans for devices. So you can start deploying lots and lots of these 5G little IoT sensors, for example. This is one that Bosch makes. It's pretty cool. You can get these for a couple dollars a piece. These are parking sensors, so you can tell when a car is in a parking space, which is pretty interesting. And it's about $10 right now for the modem, but the physical device is a lot cheaper than that. And you only get 200 kilobytes of throughput, but still, I think a lot of IoT devices, that would be just fine. There are also a lot more IoT devices coming out on the market, and every one of those devices is capable of commerce in some way. So going back to this example, you can imagine this enabling a pay-for-parking commerce app. Right, so find those parking spaces that are available, and through a mobile phone, you could pay for those spaces. When you have an abundance of inexpensive devices out there, you can do that very easily and very inexpensively, because today it's quite expensive to deploy IoT devices. I think this is the most interesting benefit to commerce, and I think this is the longest. It'll take the longest to realize this benefit. But you can execute code at a 5G tower. So think about that for a second. You have arbitrary code, maybe it's a function as a service. You can execute that at the tower, and the tower itself can respond directly to the customer. So if you're on your mobile phone, from my pocket, it goes to the tower. Tower can execute some of your code and respond directly. So the round-trip latency is about a millisecond, if you think about that. I mean, talk about instantaneous. That is truly instantaneous. And you cannot do that today with LTE. And the pieces of this are really falling into place. So we now have an increasingly robust function-as-a-service ecosystem, which is pretty remarkable. We see Lambda really exploding everywhere. Lambda's been out for a few years now. If you look at the sessions here, many of the sessions are related to serverless in some way. And the whole ecosystem around them is growing. We also see function as a service at edge starting to become a thing. So 2 years ago at AWS reInvent, Amazon released the ability to execute Lambda functions at the edge. So they have these edge locations all over the world. These are basically CDN endpoints. You can execute Lambda functions right there at that point, which is pretty remarkable. And now with this 5G and the specifications that are falling into place there, Verizon actually tested this. January 31st was the first commercial test of this. You can execute code directly at the tower. And the implications of that are pretty interesting. Of course, there's CDN, so you could serve up your app or your images. You can serve up anything from that edge. And granted, it will be more expensive, right? Because these endpoints are not, they don't have infinite storage. But you can store content and functionality there. You could also do local execution of content for personalization. So you could imagine having a kiosk where, and I know privacy would be an issue here, but imagine having it do facial recognition, and for each passerby, it says, hey, Joe, buy your favorite team's jersey. Here you go. You haven't seen this one yet, I promise you. And you could actually do that because the facial recognition could be done directly at the edge. So in real time, it could be communicating back and forth with the tower, and now the tower becomes the data center that you can then execute this personalization from. And you can do real-time targeting. And imagine if you're at a football stadium or something, and you're walking past a physical camera, right? If you are dealing with a lot of latency and a lot of, and you don't have a lot of bandwidth, it becomes very, very difficult to do personalization that's fast enough to capture that customer. And what you would want is to be able to do this in real time as the customer walks by. So immediately when you enter the frame, the personalized product that it thinks you would want should pop up right next to you. So you see it as you walk by, not after you've walked by. So I think there are a lot of really interesting implications. As Yogi Berra said, it is really difficult to predict the future, but I think there's so much bandwidth and the latency is so much less, and the ability to execute code at the edge. I think these are some of the ingredients we'll need to build next generation commerce experiences. And I don't think we'll be seeing a lot of these technologies in the next 2 years, but 5 years out, 10 years out, I think this is a pretty revolutionary technology that we'll be seeing a lot more of. And I'm excited to be part of it. All right, with that, let's take some questions. All still digesting this? Yes.
Are there any effects on human health already?
The question is...
Yeah, any effects on human health? Maybe you get cancer from 5G more easily?
Studies are mixed. Everybody has claimed that cell phone towers forever have given people cancer. I think they're widely deployed enough that it hasn't proven to be accurate yet. The actual frequency is very similar to Wi-Fi. It overlaps a lot with that. So if you think Wi-Fi can give you cancer, then you'll probably think 5G will give you cancer. I don't believe any of it. I think it's fine. I think there are radio waves everywhere of all sorts. And I guess I'm still here. So personally, I'm not worried about it, but I know some people are.
Okay, thanks.
Hey, so the question is twofold, actually. One thing I wanted to ask was when you mentioned all the mini towers, it seems that we're kind of moving in a direction where 5G itself is going to be reliant on fiber technology to some limit, right? And that's the first part. The second is there any way to for the next generation, if there's ever going to be one, sixth, seventh, whatever, to kind of build this technology in a scalable way which takes into consideration the infrastructure we have today and not reinvent new infrastructure for the next generation every time?
Yeah, so fiber is absolutely required. And what's good is, at least in the urban areas, there's lots of fiber already. But yes, fiber is an absolute necessity for this. It wouldn't make sense to use a traditional coax cable and give everybody a 3G style experience. I think cable is absolutely necessary. What's beyond 5G? Well, a certain somebody tweeted that the US was the leader in 6G technology already, even though nobody knows what 6G technology is. Whatever that is, I'm assuming it will build on top of 5G in the way that 4G built on top of 3G and 3G built on top of 2. So I assume it will be backwards compatible at least. But yeah, future-wise, I think people are going to be busy with 5G for long enough. And yeah, after I saw that tweet, I immediately Googled 6G because I thought, wow, how interesting, there's 6G out already. People are talking about it. And then I figured out that it was just invented in that one tweet. So, any other questions?
Hi, Kelly.
Hey.
Question about privacy.
Mm-hmm.
I mean, you just made up that scenario where you pass by several monitors, and every one of that can identify you and greets you, by the way, and shows you your private products that are suited for you. Do you think that's a nice scenario to live in? I ask you in private.
No. I think it's terrible. But you have to remember, Germany's on one side of the privacy spectrum. Brazilians, for example, have no problem with that at all. And I worked with a company called Netshoes that pioneered some pretty interesting technology 7 years ago that was quite similar to that. I think it's a terrible idea. I wouldn't want to live in that world. But there are a lot of folks out there. If you look at Chinese, for example, they're under constant surveillance. A lot of the Brits are as well. You know, it's said that every time you walk down a street in London, there are 6 cameras pointed at you. I think whether we like it or not, it's here. I personally don't want to be the one to write that app, though.
All right, thanks for that.
Any other questions? If anybody wants to pontificate over beers, I would be more than happy to later tonight. I think there are a lot of cool scenarios here. But at this time, they're limited to discussions about hypotheticals over beer. Any other questions? Good. All right. We'll end it here. Thank you all.